Ladies and gentlemen, thank you very much for the honor of being here. My apologies for being late because I went to a different building where they didn't have this nice room with these nice people. So this is the start. I will be talking about bridging some problems in the real world life of business and IT, and align that with the new emerging discipline of enterprise engineering. And the topic is realizing a business IT alignment using modeling instead of programming. And it is within the field of enterprise engineering, and within this engineering domain, there is the demo methodology, very important part of it. So this is the agenda. I think you can read faster than I can speak. Some practical things, some theoretical things, and so on. Well, first, what is we, who are we? Well, we're a professional company. We solve somebody else's problems. We do that we try to do that in a very solid way. Our primary customers are banks and insurance companies, and you may think, well, this is very interesting, but it's not, because we have a very big crisis in the Netherlands, in the world. Investments are very low. They are faced with huge problems on the area of governance, risk and compliance, and they have no idea what the cause of the problems is. And it is very difficult for us to tell and explain them what the nature of the problems is. But this is something I would like to convey to you this evening. But one of the major things, the roles we want to play, is bridging the academic world and the professional world, because these two worlds are very much different. Well, this is about our principles and goals, and the top one is very, very important. It's basically, enterprise engineering is about humans who cooperate in a responsible way, who communicate, and it sounds very soft, but it is not. It's very fundamental that human values, such as mentioned there, are kept, because anywhere where you find that these human values are under siege or taken away by government systems or totalitarian systems or totalitarian manufacturing procedures, you see things declining. So, the first advice we give to our customers, you want to make sure that your organization is running as good as possible. Make sure that the top condition is met. And, well, the other things are quite, well, obvious. The business is leading, not the IT. It means that the IT people are not the ones who design the business. They are not educated for that. That's not their knowledge domain. It's the business, and there's the problem. Understanding the business is the big problem. And well, we apply serious engineering methods. The basic message is state-of-the-art is not good enough, and demo and enterprise engineering's problem. Well, this is the real problem we see today. In enterprises. You have the business, where you say you've got your strategy, you've got your markets, your products, your customers, and you have your organization, which says, well, you have to structure that, you have to control it, you have to comply with governance and risk and compliance conditions. Well, there's things as quality, and then there are the IT systems. And the relations between these three domains are very unclear. Nobody is able to say, how do I capture this? From this picture describes the real problems, the crisis in IT we see today. Unfortunately, as I will argue with you, IT is not guilty. Programmers are not guilty. But we have to understand the nature of the business, we have to understand what an organization is, and we have to understand what IT systems do and should do or should not do. So this is the problem domain. Well, this is us. Well, please read this. It captures a number of things that basically the notion of business IT alignment is that you have the business, the organization working for the customer, and you can have IT systems which operate totally bug-free, but are nevertheless hardly useful for you. And the IT people, the programs say, but look, my program has 0 bugs, so it's a good program. And I used formal methods, and I used functional languages, or this technology and that technology, and still the business people say it doesn't help us. Well, this notion that this gap exists between the operation of an enterprise and the functional value, the function of the IT system, this gap is hardly being understood. This is a big problem. So, this is problem 1. Business IT alignment fails. The second problem is that IT systems, if you look at a large project in government or multinational companies, something between 40 and 70% of the projects fail. And typically some 30% are reasonably well. They deliver the results more or less as wanted. But for the remaining, either the IT project is a total failure or they get some partial results. One of our customers just spent, that's 2 years ago, 125 million euro on a very ambitious IT project, and the only thing they had is one application which allows people at the desk to check signatures. Customer comes in and they want to sign a check or to sign a document, and they can create an image of the original signature placed on some internal document and verify the signature. That application, as simple as it can be, has cost 125 million euro. That's the only result that's left. The rest, remainder, is thrown away. Now, it seems that the IT people are blamed. I think IT people are not guilty because they are able to devise very advanced software systems for GPS, GSM, medical imaging, you name it. The internet with all these rogue users still is running. Everybody tries to sabotage the internet. It is a very robust system. So that basically it's well designed in that sense. The real problem is if we give programmers specifications that are not good enough from a functional perspective, or not complete, or not coherent, or inconsistent, or with many unnoticeable inconsistency, failures, and so on, the programmers are usually not able to recognize and say, well, the specifications are not good enough. And what they deliver is usually useless. So at the end, what you typically see is that, well, the project goes bankrupt, and the project is failed, or the budget is exceeded, and well, everybody blames the IT people. Well, this is the third problem. IT systems resist the evolution. There's the notion of an agile enterprise. An agile enterprise means an enterprise who scans its environment and adopts quickly to changes in market, in product, in customer base, and so on. So if the enterprise changes, the supporting IT systems should change too. Well, by its nature of IT systems, they are very rigidly programmed, very rigidly implemented. And that is a big problem. We have to solve that. Well, basically, there are two directions you can solve that. One, that is the theory of normalized systems from Antwerp University, Professor Jan van Elst, Professor Harry Mannaert, which is an excellent approach. And the other approach is, well, avoid the programming and replace programming by model-driven architectures. Well, that is possible for a part of the domain, not for the whole domain. So these methods, these approaches are complementary. It's not a matter of competition. Well, this is about state-of-the-art, well, what the typical business consultants tell you. You hire them from KPMG or from Logica or whatever. So these three things come quickly visible when you look at what they are doing. Our question, does anybody recognize this? Anybody recognizes? Anybody says, I don't agree or disagree or... It's a controversial statement. I like to kick ass in that sense. So the message is we do not understand reality well enough, and we have these magic methods and we have this bullshit being sold by consultants. And the problem is that we have, until now, we had no reply to this. But the answer we have is enterprise engineering. And the focus is, well, the foundations of enterprise engineering are the same foundations you find in any other engineering discipline, whether it is the engineering of a car engine, or the engineering of a satellite, or the engineering of biochemical molecules. All these engineering domains are founded on the same scientific foundations as enterprise engineering. Well, the founder of enterprise engineering is Jan Lietz. He has been here some time ago. Robert, did he do a lecture here?
Yeah, he taught students the course of
okay.
Okay. Not this year, but 2 years ago.
Oh yes, I know, he was here. And well, now it's so mature that it is just as solid as physics, well, which is a very solid and clear sound science, I would say. So a number of people have done their utmost efforts to found it on good scientific foundations. Well, I will cover one or a few of these engineering issues. One of these issues, one of these foundations of engineering is the different perception of function and construction on the same artifact. And you see this illustrated. Is there anybody, who of you have followed the demo course? Okay, this sounds, and for those who didn't follow the demo course, does this make sense? The two different perspectives on a system. A functional thing, that's how you use it. It's the black box approach. You don't know what's inside. It could be a box of midgets. You never know. And that's what Jan Lietz always says. It could be a box of midgets. You have no idea what's inside, but it helps you doing your thing. And then come the technical people like us and say, well, maybe it's midgets, maybe it's transistors, maybe it's things like that. And the lady over there is only interested in driving the car from A to B. And we engineers are more focused on making the engine in such a way that the lady will be happy. That's the foundation of engineering. We engineers, we create an artifact that is useful for somebody else. In that sense, we have a very noble profession. Well, another engineering principle is the fact you make something, it works nicely, and well, it could be done better, and you're so creative enough to find small improvements, and you improve the artifact over time, incrementally, so in such a way that the functional use increases. I definitely go to the bicycle and the bike. Well, another engineering example. Just a few years ago, Boeing was able to improve the efficiency of its wings by 5%, which is an incredible improvement. How did they do it? How did they do it? Well, they used the engineering sciences, they used formal methods, models, empirical sizes, Navier-Stokes equations, and they did a validation in wind tunnels. So they made the design, the construction, they made calculations, they designed the wings, and then they tested the validation is to check whether the function is appropriate or not. If it works well, they tested it in wind tunnels, and the results of the test have been used to improve the design. The next step, so you have these design cycles where you incrementally improve your artifact. This is how Boeing people improved this efficiency. Well, who knows what this is? I'm here at people who have been educated in these things. I built such a thing myself a long time ago. And
Radio.
what?
Radio.
Yeah, radio. Yeah. And but what I tell business consultants and business architecture are not able to deliver high quality specifications of enterprises and IT systems. But we radio hobbyists were able to do that. But obviously, if you look at the mess, if you look at the total chaos, at the enormous expenses of all these failed IT projects, there is the problem. We are not able to devise high quality specifications. We must do that. Well, here's another example. It says that models are not one-dimensional things or two-dimensional things. They can be comprised of perspectives from different angles on the same engineering construction. And again, a simple contractor can build this, but the business architectures, we were not able to do this. So it's actually a plea to go to solid engineering. Well, this is the most important picture there is. It says, well, on the right you see one of the demo models. That is a proposition in a formal language about a phenomena in reality. In that case, it is a proposition. It says something about the phenomena in the reality, and that is the enterprise and the internal organization of people. If you look at the internal organization of people, what people are doing, that's a complete seamless chaos. It's just a chicken barn where at night light goes on. There's this chaos. Yet, you must understand it and make some representation like in a formal language. And the way to do it is an ontology. So an ontology has two phases. On one phase, it captures phenomena in the real world, and it says there are rules, there are the objects and the things that are there are the relations to things, and there are also forbidden relations. And the other phase of ontology, that is, there is a formal representation which is shared by stakeholders, and that's the foundation where we, computer scientists, can work on. So, you see that for enterprise engineering, that enterprises on the left are social systems. We have got the enterprise ontology, it's composed of 4 axioms, and on the right we have 4 demo aspect models, 4 propositions in a formal language that describe the enterprise completely. It's called ontological completeness, and there are all kinds of quality criteria. And if you have a representation of such an enterprise in a formal specification, you can devise a software engine. That's what I've been doing for the past years, how to design such a software engine that executes these models. So this is the foundation on which we try to work. Now, this picture says how enterprise engineering, using the demo methodology, is being applied to devise demo models of an organization. You start with the first model, then you start shared reasoning about the model with the stakeholders. You incrementally you improve it, and you have this, again, this design cycle where you incrementally improve the quality of the models until all stakeholders say, yes, this is the best representation, this is the one and only truthful representation of an ontology we have now of that enterprise. Well, at that moment, you've made a lot of progress, because we've now made the step from understanding the business. We've shown you how to devise demo model, and if we have this demo model, we also have this IT system, this software engine, which is model executing finite state automated system, and we have now a software engine that executes these models, and it does a lot without programming. There's no translation from higher level enterprise model into lower level execution language. So we have the demo modeling, model validation, model architecture, and the model simulation allows you further to study the dynamic behavior of your enterprise models, again for validation, for shared reasoning. You go step by step by step. We have available now, in a very early form, a website portal where you can make these demo models, you can simulate them, you can investigate them and see what happens, and you actually mimic the dynamic behavior of the enterprise in production. Well, this is, you all recognize this picture, do you agree? The waterfall software engineering method. Do you agree that this is the root of much evil? Do you agree or not? Well, first of all, this is typically, this is from the 80s or so, where people are being taught, well, you start with a design, and once you have your design, you start to do coding. Most people start coding before they even have a design, and they go back after coding and they re-implement their design. So I put a big red cross because that is a very bad practice. And after coding, they do some verification, testing. They call it testing. Actually, it is verification to control its internal structure. And some programmers then go back to their design and re-implement it. They change the design. They go back again to do some more coding, etc., etc. So, but this is of course a very bad practice. The only thing which is reasonably defendable is that, well, if you've written some code, you have to test it because we're all humans. So, there are the blue lines that is left. The worst blue line, the worst red line is you've made your design, your program, you coded it, you tested it, you're going to use it, you deploy it, and then you discover, it doesn't help me. My customer is not satisfied and says, I've got this problem and that problem and this doesn't work as I need. Let's change it, change the design. Well, this is precisely why all these huge IT projects fail. If they are violating these rules. So, after deployment, you have to be sure that it's working correctly. So, but with this model-driven approach we do much more. What we do is what you see on the right side, the business specification, the demo modeling, putting the models in the IT system, model simulation, model validation. And if you compare that to the problematic waterfall method, you see that the coding is gone and verification is gone because it's impossible to create incorrect models or models that can't exist in reality and so on. So you have a guaranteed flawless thing. So once you have made your model, you can deliver the system, IT system, you don't have to test it anymore, because testing is absolutely useless. We have got a concept which we call the enterprise operating system. We go again through the cycle. On the top left you have the organization, you've got the enterprise, and you have there the demo models, and you go further and you see, what does this engine provide? Well, it provides business process modeling, it provides workflow management systems. We call it the enterprise operating system because it has the same capabilities, similar capabilities as a normal operating system running on your PC. The normal operating system controls every flip-flop, register, CPU you have in the hardware you have. And the operating system provides a platform for all kinds of application programs to run in to be installed and run in a very easy way. Imagine if you have no operating system running on your computer and you want to have a few of a browser, a text editor and some more programs. Think about how incredibly difficult it would be to do that without an operating system. It would be virtually almost impossible to install these applications without an operating system. Do you agree? Okay, well, this is what this operating system does. So we have got the demo models, and all enterprise IT systems, they are running on top of this operating system. So we have an abstraction layer between enterprise IT systems, corporate IT systems, and the hardware being the people in the organization. The effect is that all these financial IT systems, the production systems, and supporting IT systems will become much easier to implement. And these will be implemented in a very different way also. And here is an enormous field of new research for the future. Well, this is this one. We've got one business case in full production. That's a company like this. It's utilities. You can buy water, electricity, and gas, and they are quite big. They have a few 100,000 customers, and if you order your gas, water, electricity, you have to sign a special contract with them. And that contract has to comply with many conditions in this business case. So this is the cases we built for one of our customers. And well, there's a lot of internal regulations that has to be met, a lot of documents that have to be produced. Each contract is tailor-made, so that's quite difficult to capture. And what we did is we made a demo model. Well, this is the actual demo model we devised from this business procedure. I'm not going to explain this model because that's not relevant. But it shows that this model is being executed by the demo engine, and we estimate some 80% reduction in programming, in number of lines. The joke is that and that happened a few times, that the company says, yes, we are facing with changing regulations, or we want to do things in a slightly different way. They only have to change the model on the left. They put it in a machine, and from that moment on, the whole organization runs according to the new business model. So that model tells everybody how to work, what to do, what the sequences is, and it is impossible for the people in the company to deviate, to work in another way outside the state space of this model. Well, it runs. customer satisfied. They're not really interested in why we did this that way. They simply say, well, we expect you to deliver a good working program. Yeah, we're not interested in all these technical things. So, well, also finally, we have a lot of new research topics where a technical university could be, could do a lot of good work. This afternoon I had a further discussion with Robert Perger, and some more ideas came up. So it is a very new engineering field. There's a lot of things to be done. Some very serious technical problems have to be solved. Well, this is what we have for future research, and we have also much more. Well, this is what we think the future may look like. IT systems becoming a commodity, cheap. You develop models, you send them to somebody else, and a short time later you receive your IT system, and that's it. Cheap, mass-produced manufacturing, just like well, the type of work well, you find in China, something like that, mass production of IT systems. This won't go to China, but this is what we expect. It will go into this direction. What it really means that the real focus of engineering will focus on the functional qualities of an enterprise and the efforts to devise high-quality models. Good. This is it. The red line in the bottom, that's very, very important. That's a key notion. We think that the best way to let an organization run is that the people of the organization devise their own business models, because they are responsible for the customer. They should design their way of working, and we should help them in doing so. But yeah, this is what we believe the future will go. Maybe not completely, I don't think so, but quite a large step into that direction. Now, why should we do this research in enterprise engineering? Well, first of all, the biggest one is we can solve a big problem in society. We can give excellent education to students with capabilities that solve the problems. There's a lot of research to be done. Society will benefit, university will benefit, science will benefit. That's how I look at it, and yeah, I like this sequence of pictures. We are very much at it somewhere there at the beginning. We've got a few things that fly already a little bit, but well, much more is to be done. So on the right you see what might be something like our future. Thank you, ladies and gentlemen. Do you have any questions, or do you oppose the visions presented here to you? That's also possible, that you don't agree.
May I start?
Yes.
I would say that there is no arguments which I would like to raise, but I was really impressed with the idea how to simplify the whole process and the alignment with business. Now,
yes.
when we say that, you have already tried several times to sell demo to many enterprises, haven't you?
Yes. Yes.
What is your experience? What would you say is the main obstacle or barrier to implement demo easily and successfully on the customer side?
That's an excellent question. That's one of the key problems we have. I can answer this question from several perspectives. First of all, we are very little guys, and if we open our mouth, it will be so much. And especially in the Netherlands, big corporations do only business with big consulting firms. And the big consulting firms are only interested in eating the budget of these large. That's the only thing that's really happening. They don't like people who say, well, you're making a mess or whatever. So there is a big barrier for us with our little mouth to say, well, he's doing this right or that is bullshit and so on. Nobody believes us. The only way to make people believe us is cooperation with scientific research institutes and universities, because we are scientists. We are supposed, and that's a really almost sacred obligation, to tell the truth, the scientific truth, as well as we understand. And in general, well, scientists, they are credible people. Salespeople, nobody trusts them anymore. Bankers, nobody trusts them anymore. Politicians, nobody trusts them anymore. Scientists, well, you can trust them. Especially engineers. So, yeah, well, they don't have they only have the focus on their job. So to answer your question, first of all, yes, it's very difficult to raise our voice, and the only way to do it is convinced with facts. The second thing, and that is a more practical, strategic issue we would have, what we want to do, and we want to do that together with Robert Pergel and some other people, we need more empirical evidence of real business cases that we can solve. We think that in banking and financial services there are huge problems with governance, risk and compliance. And governance means that the organization operates according to internal principles. Risk means how do you identify and mitigate risks during the operation. And compliance, you have to comply with Basel 1, 2, 3, 4, Sarbanes-Oxley, and how to implement that. That is where we see the major problem. We need some more empirical cases that we can handle these problems. Business cases, not too simple, not too big. We need this to have empirical evidence. Once we have that, I will go to the president of the National Bank in the Netherlands. I will knock on his door and say, we think we have the right engineering approach for these problems you have. At that moment, it is almost impossible for him to say, I'm not interested. He has to investigate it, whether it's bullshit or not. Because maybe it's not bullshit. So maybe it could be true. So this is the second answer to your question. We need business cases. We need business cases to get some more empirical evidence. And then we can go to the big players. The third thing is, well, if we can convince these highly placed people with big problems. I've heard that some of these people don't sleep well at night. Well, these people are the exceptions because they have a conscience. Most of them don't have a conscience, so these people sleep very well. But yeah, that is our personal. This is the strategy which I also discussed with Robert Pergel, how to circumvent it. But you're right, it is very difficult to sell the demo. Then there's a fourth problem. People look at demo and say, I don't understand anything in it. They see this simple drawing with these boxes and a circle and the lines and a few things. And there's a demo professional who says, well, here's your model. And he says, yeah, what is it? And then comes another guy, he brings a BPMN model with him. Says, look, that's happening, that's happening. He will say, yes, that's what I understand, I like it. But BPMN is a disaster. It is absolutely a disaster. But it's much easier to sell. This is so abstract, so formalized that, well, yeah, only engineers understand it. However, one other thing is that this model on the left has been designed together with the staff of that company, And they were able to understand, okay, first you do this, and then we do that, and then we do that. So it is possible that people understand it. So, this is my answer to your question, sir. It is a very important question.
Understood.
Yeah.
So what was the main difference between demo model and BPM model?
Oh, yes. BPMN model is not founded on an ontology in a formal way. So it doesn't define precisely the concept. In fact, BPMN has many concepts, and there is a problem which is called, in ontology theory, a concept overload. Another problem is that there's no abstraction between the implementation, independent design, and a specific implementation, and Robert can explain that very precisely. A third fundamental problem is that it is not a formal specification. So it's people who say, we have an engine that executes BPMN. Well, some of them have been saying that, but actually that's not possible because it is not a formal specification. It is impossible to devise a machine that executes BPMN models. The fourth problem with BPMN is ontological incompleteness. Well, you can design the happy flow, the normal process steps of execution, but that will work reasonably well in practice. But if anything strange happens, there's a rollback of processes. Well, this is almost impossible to capture in BPMN. I can simply show that if I would draw this scheme here in BPMN, I would need precisely somewhere 52 pages in BPMN. From this model, I can make by hand a BPM model which is functionally equivalent to this, but I will need 52 times because, well, you see this circle, which is only a circle, but underneath this circle is a complete communication pattern. And we have a very simple symbol for that. But there's a lot of information, a lot of structure under these models. These models are very highly abstract representations. Well, for reasons it doesn't work well. But people like BPMN.
And Demo Engine, you mentioned it's your company's business product, which is based for producing the software, based on the
we've got two activities. We make information systems for banks and insurance companies, these kind, and from time to time we get a project, not much because the investment levels are very low, and life, well, okay, we're surviving, but it's tough business. But from time to time we make these systems. But we want to, what we really want to do is to have this engine available for everybody, for students, and so for a very low price, say the price of a book. For professionals, they pay some fee for if you use the modeling environment. And it's also a production system that will run as a web service, and you only make your models and everything is complete, and you don't have to invest in software licenses, you simply run the engine. So it will be very cheap to use, but that's the business model we are aiming at.
So there is a lot of work to do still.
Yes. It's a mountains of work.
Could you go back to the slide with that model simulation, model validation? There was such a slide with
you. Yeah, I will go back, and you say stop.
If you could comment more on that from the perspective of what
this one? No,
the previous one.
Again, back. Yeah.
This one. Oh,
yeah, okay.
Sorry. Because we are a faculty which educates in software engineering.
Yes.
So what I'm interested in, how much work for student projects is in developing such a framework which makes all these 4 phases of development easier by providing software tools.
We have also made some plans with Robert on that topic. we have one student. He is from Costa Rica, and he is going to pick an ITIL procedure. Are you familiar with ITIL? He is going to pick one of them. It is a best practice approach. It is represented in flowcharts, so there are all kinds of hidden problems in flowcharts. What he should do is to devise a demo model based on the purpose of the function of this ITIL business procedure, simulate it, design the best implementation, and make it running, and delivering some kind of a cookbook, meaning, okay, here's this problem, this ITIL procedure is not good, I did it with demo, I validated, went through the steps, and these are the advantages. The advantages are quite big. My business partner did a master's thesis at the Antwerp University and did also this, and the impact is very large. So that's another area where we can be successful and solve real life problems in detail. Also equally interesting is COVID. You're familiar with COVID?
Not much.
Okay, but that's more about the internal procedures, making sure that your IT systems are available and so on. It's much more vague, and it's more in the domain of governance, devising the procedures and implementing the procedures, that strategy decisions are being implemented and carried out. We have a global recipe how to address them, but that's also new. But with Robert, we discussed this idea that Czech University could be the competence center for ITIL, and say to the whole world, well, you're doing this ITIL, but you can do much better using enterprise engineering. That's one thing we just interesting idea. Another idea which Robert came is that we have a procedure for assessment of master's theses and bachelor theses, and these have to be assessed, and there's various production steps in there. And could that be done with demo? Yes, because with these tools, yes, that can. And that could be some kind of a foundation services provided to other universities. Could also be a source of income for the universities to hire more people and so on.
Well, let me say a few words to this. We implemented here the faculty, the process-oriented information system for bachelor and master thesis. Some of you already have some experience with that.
Infamous system.
And if I take apart the technical issues that come from the platform of IBM and its configuration and things like that, it's a huge success because the system is based on process model, and you can even, as a user, you can click and you can see where you are in the process and what is happening and what will happen next. So this is very, very important because usually as systems are built, and previous systems were built, was that there is no model and everything is hard-coded. So if some regulations change now, the changing of the system will be much more easier and flexible, and again you will see where you are and what will happen. This is a huge success. But at the same time, you can always be better and better, and the way to become better is this approach also. So what we are saying with Steve, that we can experimentally, we will build a system using demo and see how this compares on a conceptual level, right? We are not speaking now about how much load of requests the system can handle. Of course, this is not something that we are now doing. We are speaking about conceptual level because, for example, right now, if you click on the process of the diploma thesis, you will see different boxes, and one of them says approval of the thesis by Dean. This is fine. This should be there. But at the same time, there is another box that says assign ID to thesis. This is something very technical that you are not interested in as a user. And the reason why there are so many boxes, mixed boxes which you are interested in, mixed boxes which are technical, is that what Steve already mentioned, the BPMN doesn't discern clearly the ontological level and implementation level, and they are all mixed together. Well, in demo, as you could see, our module would be much more easy to read, much more concise. Those three C's: concise, coherent, and so on, complete. And at the same time, it should provide the same functionality. So this is something we want to pursue, and we want to test. As you already heard, we are cooperating, the faculty and Informatický. We already have one bachelor thesis focused on demo, one project of Erasmus student. And if you are interested, then you are also welcome to join those interesting things. There is a lot of work, a lot of ideas, as you could see. When you are thinking now about your more questions, I will route to the Blackboard, the web page of our group.
Hang on, please. Let's stay with this picture. Still, look, I have such an ordinary comment, I would say. If you want to keep your customer happy,
Yes.
then obviously you have to be able to provide him with some feedback during the since the start of the
Yes.
yes. Yeah. What would be your suggestion? How frequently you would suggest to run a steering committee with customer, with the stakeholders? Because they need to know and to believe that something after some time will really come. So, what is the, let's say, sub-result which we can offer at some steering committee? How this looks like? So, what is your comment?
Okay. Yeah. Basically, it's not when we start a project. We start a work group, and the most important participants are the people of the organizations themselves.
Stakeholders, yes.
Yeah, stakeholders. And we explain the stakeholders how it works and in global terms. And it's basically the stakeholders, we help them design their own organization. And that is quite a time-consuming job. But any time spent here, you earn back 10 times or 100 times more later. So really, this is the key. This is human engineering, or knowledge engineering, and so on. But within, if you have a business case which is not too complex, but certainly not too trivial, we typically have in 2, 3, 4 days. We have gone through this whole process, and we have made such a demo model there, and we put it in the machine, and we can simulate it, all the steps to it. If this happens, then that happens, and so on, the whole communication. And then the stakeholders can say, yes, I agree, this is the way it should be done. In this, if we take this model, we comply with external regulations, internal policies, and so on. That's one step. Then we would like to do another step within a few days, and to add an adaptive case management systems for the production of documents. We do this very simply, but at that moment you have an application which is primitive, but can be used immediately in production. It's ready for production. So you have at that time you have an IT system that addresses the business IT alignment problem.
I have some other questions, but it's not necessary to raise that because we have fixed this road by the meeting with you for tomorrow.
Yes,
so
of course.
We can
Yeah,
discuss that one-on-one. Okay.
More questions? Well, I'm expecting some very critical questions from the legal professionals.
You made a statement that maybe I misunderstood, but on one side you have chaotic company, enterprise.
Yes.
On the other side you have clear, well-defined, semantically, ontologically defined demo model.
Yes. Yes.
how do you cover the gap between the chaos and the order in the model?
Okay, yes. It's this picture, and well, it's an ontology, and says basically ontology is about throwing everything away that you don't need, and keeping only those elements that are relevant. Mm-hmm. The problem is, how do you know that these concepts or objects are relevant? Well, that is something that's covered by the theory of ontology, the appropriate the truthfulness qualities of ontology. But, well, it's basically, enterprise ontology is a hypothesis, and it's subject to Popper's falsification laws. So far, it seems to work. Maybe one day somebody comes and says, proves, well, enterprise ontology is flawed. Just one case is enough, and then enterprise ontology, including all what I said this evening, is that going that direction. But keep things crossed. So far, nobody came up with a proof, disproof of Popper's falsification law. But yeah, that's well. We think this works, and this confidence is increased by more and more business applications, and we have already quite a big body of business cases which show it works here, it works there, it works there, it works there. But to address the problems of governance, risk, and compliance in the large banking conglomerates, I want to, if the moment I knock on their door, I want to have more cases in this specific field, really proven. That's it. That's it. But this is the core importance of an ontology, to try to understand some phenomena in the world. Well, it's vague. It's you only can validate it. You can until you disprove it, and empirical sciences. Okay.
Maybe a lot of people here are like software engineers.
Yes.
You are interested in implementation. Maybe I know this, but maybe you could for the others a little bit more about this last step of transforming the demo model or running the demo model on the machine, like the information system. Maybe a little bit like feel like magic now. How from the demo model there is something running on the machine without programming or without minor programming.
Yeah. Well, but basically it's a computer science question. If you have a domain ontology, and it's really a formal, explicit specification, then it's possible to devise a language that can be used to specify propositions on the domain. And you can, the same theory tells that you can devise a software engine that, well, it's implemented using an object-oriented approach, of course, but it is a native interpreter machine that interprets it, that understands the concepts of enterprise ontology. So it understands what an actor is, and an initiator, and the executor, and a transaction, and so on. That's what it understands. It doesn't understand the concept real number. We don't have that, and we don't have things like an integer number or the normal programming primitives. These are very low level. We have actually very simple engine, and the only thing this engine can do is execute anything within this domain ontology. So it is a limited machine with limited expressiveness, as much as possible. It is impossible to make a model of an enterprise which cannot exist in reality. It's impossible. Also, it means also that any enterprise, if you model it, can be represented by guaranteed one model. not 2, not 0. There's one and only model that gives a true representation of an enterprise. It's not possible to make 2 models which are functionally identical. It's impossible. So it becomes a very primitive, very simple thing altogether. There's all those problems. If you start writing a programming in Java, and you write a programming, you write a program, I write a program, all the 3 programs will be different implementations, different algorithms maybe, or whatever, and all these programs can be correct. But the problem with these low-level programming languages is you have too much design freedom. Your expressiveness is too large. The expressiveness of this engine is minimized precisely to any model, to any enterprise that may exist in reality. So it's impossible to make illegal enterprises, and it's guaranteed that any enterprise is represented by only one model. So it becomes very simple.
And all these statements are proven?
What is being proven? Yes. Well, it is theoretically there is a logic system below it, informal specifications, predicate logic, and so on.
So, is it correct to say that it's something like analogy? If you have a computer and you have a Java virtual machine, which gives you sort of layer abstraction that you can speak with objects and send messages and things like that. And this is sort of this like layer that runs on your computer, and it understands actors and transactions.
Yes. There is a communication facility with actors. An actor he has a freedom, but he is not able to act outside the state space of the model. And of course an actor has freedom. If you're familiar with the demo, if I do a request to you, do something for me, you can say, yes, I do it, or you can say, no, I don't. You have this freedom, but you have not the freedom to do something else. So you suppose if you say, I do a promise, I do it for you, you're expected to do it, and so on. So it is a prescriptive control of the enterprise, of the people in the enterprise. They cannot work outside the state space of the model. So it guarantees that in banking, people follow the procedures precisely and not do all kinds of silly things outside which may pose risk. Did I answer your question?
So if we will think about redesigning our information system for student agenda, would you be willing to experiment with this approach to do it?
Yes, absolutely. Yes.
Dat ik coach heb, is wat we doen.
Yeah, I would be a little bit like cautious in a way that, of course, this doesn't cover user interface things. For example, designing user interface to be to include the most high-tech technologies. Those are like things that you need to take care separately, and unfortunately, those are the things that make the user experience the biggest. So, our goal now is to prove the concept of designing the system, and yeah, I would not be too hasty to put a production system based on this, because once the user interface is not good, then the people will say, oh, demo is a horrible thing, it produces such horrible systems. Few people would understand that those are two separate things. Ajax and JavaScript and demo here, right?
There's still a lot of standard programming left, but the core, the business processes being followed, the control of the organizations, the knowing of each elementary act and fact. Well, we have the operating system, but on top, well, many applications are needed, and that's outside our scope. All right, thank you very much. It was a pleasure to be with you at the University of Technology.